So hello everyone, welcome to the Statistical Society of Australia's March webinar. What a month it has been. We are so glad you could join us. I'm Susanna Cram and I'll be the chair for today. As usual, as Mark mentioned, questions will occur at the end, but you're welcome to type your questions in the chat window throughout. And I'll read these out to Marijke right at the end during question time. So we're delighted to have Marijke speaking today. Dr. Marijke Welvaert has worked on many different projects in multiple countries and is now part of the Statistical Consulting Unit at the Australian National University. She shares more about her journey in this talk. So over to you, Marijke.
Thank you, Susanna. Good afternoon, everyone. I'll probably just have to apologize first for my voice. I've been home with a chest infection all week, and it's a very weird time to have quite a common thing because everyone is looking at you like you're going to spread the next world pandemic. But I'm hoping I'll be able to get through my presentation without too much coughing. If I do get into a coughing fit, please free to turn down volume a bit. This is the first time I'm doing a webinar. It's a bit weird for me actually not seeing who I'm talking to, because normally I rely on the faces of my audience, but we'll see how we go. So today's talk is a bit literally about my journey and how I became to be a statistician and some tales I collected along the way. When I finished high school, I actually wanted to become a child psychologist. And I wanted to help children in need of mental health support. Interesting enough, the first year in psychology at Ghent University in Belgium, where I was living, did not have any specific child psychology courses, so I had to sit through the 12 courses that were part of the first year. And in Belgium, the system is that, you get two chances at passing a course. One is the exam during the year, and if you don't pass that one, you get a second attempt during the summer holidays. So after my first year, I passed 5 of the 12 courses. Unfortunately. So there was a bit of a panic, and interestingly enough, the courses I passed were like genetics, physiology, so the more kind of what you would call the more hardcore science one, I guess, and none of my psychology courses. So obviously my parents were a bit in a panic, and they sent me to the student guidance counselor who helps students with advice on how to study and how to get through that second attempt of the exams. And when I got to the appointment, it actually only lasted 5 minutes, because the comment I got was, "You passed statistics, what are you complaining about?" So as one of the few students, I had passed statistics, and probably that should have told me already something there. Anyway, along the course of my studies in psychology, I ended up choosing the more cognitive side of things and the more theoretical side of things, and ended up doing a research master's. And for my research master's, I had to complete 2 projects, and that's where my 2 first tales begin. And those are also the ones who motivated me to then actually pursue a career in statistics rather than psychology. All right. So the first research project turned out to be my master thesis. I was looking at how we process numbers. So my supervisor at that time had developed a neural network model that was able to distinguish between odd and even numbers. So a fairly simple task, but in terms of actually getting a model to learn that, that was quite involved. So what he had observed was that there was a learning curve in the model, and he wanted to find out if that was similar to the learning curve that we see with children who are learning about numbers. So my task for my master thesis was to go out in schools and find out how children learn odd and even, and then test their capability in the number judgment using a reaction time task. And these are very common within cognitive psychology. So basically, you put someone in front of a computer, give them a few buttons to click, and they need to perform a task. So on the screen, you see an overview of what a task sequence may look like. So you get some fixation cross, then you get some target, and then you need to perform a judgment on that target. And in my case, that was judging whether the number was odd or even. So typically these designs are within subject design. So you run the subject through several conditions and you do a number of repeats on each trial. So in the end, you have this repeated measures design. And traditionally that was analyzed at the time with the repeated measures ANOVA. So I went to my supervisor with my results, which I had analysed using that repeated measures ANOVA, and he said, "Oh no, there's this thing that people do these days, which may be better. It's called log and mice analysis." I hadn't learned about that in my statistics courses, so that was interesting. So I was sent away with the article, and basically log and mice analysis was developed for unbalanced designs. So the kind of designs that no longer easily fit within the standard repeated measures ANOVA setup. And basically it has a two-stage approach. So in the first stage, you fit individual regression curves depending on your design. That will determine which variables are in there, but you get estimates for each individual separately. And then in the second stage, you combine your estimates to then get inference on a group level. In other areas, it's also known as a summary statistics kind of approach. So I went out to do that. It actually did not change my results at all, interestingly. But I think you all are thinking now, when you hear the story, like, why did you not just apply a hierarchical model or a linear mixed model? And that's indeed what the field then discovered just right about the time that I was submitting my thesis, that people had been applying this method to analyze repeated measures data, but there were actually more flexible approaches like the linear mixed model that had a much wider applicability. So this was kind of an example of something that, an analysis method that in itself probably wasn't wrong, was trying to address an issue, but then had certain limitations and then was overtaken by a more common approach that was not very field specific. And you'll see throughout the presentation, I will point out two methods that live in specific fields or domains, as these are kind of the basis of all my tales. So that was that research project. The second one I did was part of an internship. So I got to live in the south of France for half a year and do my research there. And you may have seen this writing somewhere. So interestingly enough, when we read, we can do a lot with words before they actually become unreadable. So as long as the first and last letter is in place, we actually are still capable of reading these words. Which is very interesting in psycholinguistics, so the field that studies how we process word recognition and language. This is this is like the basis of a lot of theories and models around how we represent language in our brains. So for my research project, I looked at a specific type of manipulation to investigate these types of models. So this is again reaction time experiments. So the setup was very similar. The only difference is that before the participants got a target where they had to judge whether it was a word or a non-word. So you basically get a letter of strings on the screen, and you have to decide whether it was a word or non-word. In this case, it was in French, since we were in France there. And just before they saw the target, rather, they actually got a 30 millisecond prime. So this is subliminal priming of a similar string or a different unrelated string, depending on the condition. And we looked at the impact of the prime on the reaction time on the target. So the idea was that depending on the prime condition, reaction time may be faster if it was facilitating word recognition, or slower if it was hindering word recognition. So with these psycholinguistic experiments, it's key to realize that we are working with two sets of measurement units. So we get, again, repeated measurements because each trial is repeated several times for each subject. So we have multiple subjects in our experiment, but because we are using targeted words that are coming from the language, we also made a random selection of these items, we call them. So we have a subject pool, which is randomly drawn for the population, and an item pool that's randomly drawn. When I was there doing my internship, I was told that to do a standard psycholinguistic analysis. So this was another analysis method that was very specific for that field, which deals with the fact that you have these two populations. So basically, you perform two separate repeated measure ANOVA analyses. So they're called F1 and F2. F1 refers to subjects, F2 to the items. And F1 analysis is creating by averaging within each condition over all your items for each subject. So the result is that for each subject, you get an average reaction time per condition, rather than having individual reaction times for each item within conditions. Yeah? And then for the F2 analysis, you do exactly the opposite. So rather than having averages for subjects, you now create averages for per item, and you average across subjects within each condition again. So according to my supervisor, the advantage was that even for missing cells, averaging gives you a mean value for each condition for each subject item. That was particularly important because with reaction time analysis, there's typically a data cleaning that is being done. There's, again, different methods. It's not unified, but for example, one of the arguments is if your reaction time is under 200 milliseconds, it's too fast for you to have performed a cognitive process. Therefore, the actual reaction time hasn't measured what you want to measure, so you should discard those. And if it's, for example, over 1.5 seconds, it's been too long and the participant probably wasn't paying attention, so you discard those too. So it's very typical to create some missing values in your data set, and then you actually have to cope with them in your analysis process. Whilst I was doing that, no reference for this analysis was provided, and so it was considered a very common practice. I did the analysis, and the paper that came out of that research was published with that particular analysis. But at the same time, our statistics professor had already alerted that there was an issue with this, and that there was some kind of movement against this type of analysis because no one really understood where it was coming from. So when I was doing my master's in statistics, then I actually went down and investigated where it was coming from and if it was indeed the correct thing to do. So we had to go down to 1973. And that's an article by Clark, excuse me for a second. So this article by Clark really pointed out the fact that with psycholinguistic experiments, you do have two populations, and you draw samples from both populations. And up until that point, he said this was ignored as they performed only the by-subject analysis. So his recommendation was to indeed do combined F1 and F2 analysis. But then the next step was forgotten in the next 30 years of research was to actually combine those two analyses to a minus F prime analysis. This avoided the problem that, you ran into scenarios where your F1 analysis was significant and your F2 analysis wasn't. All right. So in my thesis, I looked at the actual type 1 error and power characteristics of this analysis compared to a linear mixed model with cross-random effects. round about the time that I was submitting my thesis, this article was published. So exactly alerting to the F1, F2 story, and that there was a problem with, so we did find inflated sub-1 errors and lower power with that method, and which you wouldn't have with a mixed model with cross-random effects. So unfortunately, I didn't get to publish my work, but the good news is that since this article by Brian and his colleagues, and you see also Douglas Bates from the LME4 package included there, since this article, psycholinguistics rather, has completely changed the way they analyze their data, and so F1, F2 analysis is actually pretty uncommon these days, and I'm sure if someone would do it in a review process, it would be rejected. So I think it's quite good to see that even though there was this common practice in the field for so many years, that just one influential paper that points out the flaws with it actually resulted in changing that analysis approach. All right, so finishing up my master's there, I stayed basically with my supervisor for that master thesis, and at the time fMRI was a buzzword, and he was being tasked by the dean of the faculty to investigate how the Department of Data Analysis could play a role in fMRI and what we could do. So the motivating example for why we thought statistics needed to have a look at fMRI was this poster presentation by Craig Bennett at the Human Brain Mapping Conference in 2009. So this is pretty much one of the biggest gatherings of people involved and that's studying the brain. So what they did is get a salmon from the fish market, I presume, and put it in an fMRI scanner. They made the salmon watch a series of photos, measured the brain at the same time, so took brain pictures, and then analyzed those scans using the standard protocol that was common in that field. And in the end, you get this red blob. And the red blob is basically the holy grail for neuroimaging scientists, because that means you can publish a paper because that shows where the activation in the brain actually is. So they had this nice red blob in their dead salmon. So dead salmons actually are capable of differentiating between emotions in pictures. Obviously, it was all meant as a bit of a joke, but it did point to a big gap in the area, that they were all relying on statistics that were used without thinking, basically. So no one really understood what they're doing. They were just putting things in software and then trusting what the software spit out. The biggest problem is that when you have an fMRI data set, you have a four-dimensional data set, which is split up in voxels and time. So you have basically your pixels over time. And the standard method fits a time series per voxel, and then basically creates a cutoff to decide which voxel shows a significant change over time. As you can imagine, when you perform on average 100,000 of these, because that's kind of the average number of voxels you would get, that you have a massive multiple testing problem. So this pointed out that there is indeed an issue there, and that people really couldn't publish any results anymore without accounting for the multiple testing. So that was one big area of research at that time. What I did was actually focus on a different aspect, is that 40 voxel-wise estimation standard GLM was used, and with a Gaussian noise. And there had been several studies that fMRI noise has lots of other components that are non-Gaussian. So we looked at some simulation studies that showed that indeed depending on the noise model that went into the simulated data, the SPM analysis showed different results compared to another kind of analysis when you actually start comparing those. So I guess the field has definitely moved on these days, and they're doing a lot around pattern recognition more than standard GLM approaches. But it's another story of how a field kind of emerges and takes a statistical approach which fits their concept of what they're trying to analyze and what they're trying to look at. But then when you look at the finer detail of it, there's some issues that they hadn't addressed, and that definitely needed involvement of statisticians to actually be improved on. Okay, so that was my PhD. After my PhD, I had the privilege of coming to Australia, and I became a moth hunter. So I did a postdoc at CSIRO, which was very interesting in terms that we got to look at citizen science and all sorts of general public generated data streams and their usefulness for biosecurity surveillance. So in order to actually validate some of those data streams, we had to go collect our own data. So what started as a fun project that we kind of thought up on a Friday afternoon in the pub became a weekly march up to Mount Jintra, which is one of our higher jobs here in Canberra, and count the bokor moths over there. So I guess as a statistician, it's not maybe not that common to be out there and collect your own data, but it's something I really highly recommend. If not collecting your own data, at least understanding how data are collected. And this is kind of what I did in my next job at University of Canberra. I was a statistical consultant for the Research Institute for Sport and Exercise there, and I volunteered myself a few times to see what their data collection process is, to really truly understand what is involved in collecting the data. So I got a better idea rather than just kind of relying on what they tell me, what we actually had to take into account. And there's definitely been a few instances where I did not get the full story because they didn't quite realize that a certain aspect in their protocol did have implications for the statistical analysis. Being in the sport area, that led me to my final tale. And it's unfortunately, while my 3 previous tales were rather successful in that, a method that was very common was kind of disproven and then subsequently no longer used. This is not the case. You may or may not have seen this in some media. It pops up from time to time, but this is something that is very common in sports research and has now for a few years now been critiqued by statisticians across the world. So it's called magnitude-based inference. Without going into too much detail, it is an Excel spreadsheet where you dump your data in. There's different design scenarios, but they're fairly limited. You get the standard statistics as you effect statistic and p-value and degrees of freedom, a confidence interval, but where the difference is that you also need to provide a minimal worthwhile change. So rather than using the null hypothesis as a testing against null, they want you to think about what is actually worthwhile. So, for example, with the dietitians I work with, if they're looking at weight loss studies, they often refer to that 5% body weight loss, which is for them the market that, you know, it's clinically meaningful change. So they use that clinically meaningful change to evaluate the confidence interval that you get from your statistics. Which is all good and well to put a qualitative kind of wording around, you know, my meaningful change is included in confidence interval or not included, therefore this may not be as meaningful or is very meaningful. But they go a step further and actually assign probabilities to that it actually is likely beneficial or it might be harmful, etc., etc. The interesting thing is that this is supposedly working in very small samples, and I'm talking samples definitely smaller than 10, often on variables that are highly variable. There have been 2 formal statistical reviews. There's probably a couple of more, but actually 2 that have named magnitude-based inference by name. And I think as statisticians, we often, or at least I do, get the comment that I never answer in black and white. So we always kind of, you know, sit in this gray zone and, you know, it could be this or it could be that. But these 2 reviews leave no room for interpretation and basically say, do not use magnitude-based inference. So the first one was commissioned by the Australian Institute of Sport. So Emma Knight was working as a statistician there at the time, and Alan Welsh from the ANU was asked to collaborate with her to actually evaluate magnitude-based inference. They did a thorough job at replicating everything that the spreadsheets do in R, and then use that R code to run some standard kind of simulation type approaches to assess type 1 error and etc. And they found inflated type 1 error rates up to 75%. So that's pretty clear, I think, that, you know, that there might be some issue with the method. Unfortunately, that wasn't really followed, and things kept going on. So this was published in 2015. So 2018, things boiled up again, and Christine Sinani from Stanford also looked at it. So basically looked at Alan's and Emma's work, replicated that, and also wrote out the mathematics behind it, and that also showed that there is a serious issue, and also she ends with magnitude-based inference should not be used. At this point in time, I think all of us would think that these are very clear and strong recommendations, and that, like any of the other papers that were published that maybe didn't even use that strong language, you would expect that people change their behavior and look at other methods to analyze their data. But unfortunately, there's a very, very strong group who's advertising for magnitude-based inference. I'm afraid to say that they don't really use any scientific reasoning to prove their point, or at least counteract the criticisms. And it's often to see these kinds of lines. So this paper starts with, I am not a qualified statistician, but after 20 years of sport research and applied field work with elite athletes, I consider myself an experienced user of statistics. And that's for them enough to actually basically dismiss the work that had been done by statisticians and put their own spin on things. It's an interesting debate, and unfortunately it's no longer about science. I did use the word cult, and it's because I have seen it from close, and I actually know that people are still using magnitude-based inference. So it's really hard to understand why that's the case. So I think as far as I can tell, 2 main reasons would be the very strong advocates that have a very large standing in the field. As long as they are there, it will be really hard to convince that group, which is relatively small, I have to say, but to convince that group that, you know, that they should listen and change what they do, or at least if they do think this is like the new statistics as they claim to be, publish it in a statistics journal and you know, put it open to peer review within the fields that they are claiming this to be sitting. The other thing I think from the sports scientist point of view, unfortunately, they do come with a background that has very limited statistics education. And while there is a lot of goodwill, I think they do struggle to find that support to step away from that easiness of having that spreadsheet where you put your data in and you know, try to apply more rigorous methods. So there's no immediate solution to that, I think, and unfortunately I think it will go on for a bit. So if you see this pop up, hopefully this has given you some background around this. Okay, so those are basically my tells. So a few morals of the story, so a few reflections that I have made along the way and that I try to kind of use in my daily job as a statistical consultant, is that there is a method to application lag. So if we look at the first two tells, basically both methods were replaced with a linear mixed model. At the time that those methods were used, linear mixed model already had been developed and already was being used within statistics and especially medicine, I think, because there was that general link that statisticians used with medicine to progress these models, but that hadn't trickled through in other fields. So whilst this is probably better these days with open software like R, where if you haven't developed new statistical methods, chances are you also will write an R package to kind of support that method. I think it's important for us to realize that there is that lag, and it's not just a lag in availability of the software to do the analysis, but also the education lag that actually other application domains pick up on the method and then see the benefit of it and actually then are being shown how it applies in their specific field. The second thing I thought was the elusiveness of the domain-specific methods. So each of my tales had a method that was developed within a domain. So rather than having a statistical method that is then applied to a certain domain, it was based on a domain-specific need. An analysis protocol was constructed, and that protocol stayed within that domain without actually going outside of that specific area. It is very attractive, I think, for those researchers to, first of all, use what they are being told to use by their supervisors. So there's this natural kind of survival of these methods within the domain, but also because when they publish it, reviewers don't question it, because this is exactly what reviews do. So there's this self-fulfilling kind of reinforcement of, yes, you are doing the right analysis. And it's only until either someone dares to think outside of the box or some outsider steps in that maybe they actually are being pointed towards some limitations of their method or things that they haven't taken into account. So I think it is probably quite common in a lot of domains. And for us as statisticians, when you work with someone in a specific domain and you may be new to the domain, I find it always very important to listen first and to not dismiss at hand what they are doing, but have a listen and try to find out where it's coming from. It builds that connection, I think, and it helps us to be seen as an actual advisor to them and help them improve as well as with their statistics. Is an interesting one, and I guess this is mainly the few years I probably was in sports science, but there's a certain questioning of statisticians' expertise or the recognition of statistics as a field on its own, so research field on its own. I had to use the lines a few times that, you know, you are having a statistical argument with me, so but I would never dare to argue within your domain. You're the content expert there. So it's interesting, I think, and this is obviously, especially in the light of the whole magnitude-based inference kind of story, is that there is that criticism towards a field or an area in which we are experts. And it's not to say that we're always right, but there's this kind of instant like, oh yeah, but I have been using statistics for 20 years, so therefore I'm an expert. I would be very reluctant to make similar claims in other domains, even if you have been there for long, and probably you also know a lot about that domain. I think we're probably a bit more reluctant to make such claims. And then I guess my last advice, and maybe if there's any young statisticians listening in today, would be to get your hands dirty. I found it so important to build a connection with, if it's a researcher you're collaborating with, or if it's a client you're consulting with, to make sure you understand where they're coming from, what they're talking about, so they can talk to you in their language, which makes it a lot easier for them. And you understand that if they tell you a certain story, that you need to maybe ask very specific questions to make sure that you've had the full story of their data collection. Because often there's these standard protocols which have impact on your analysis, but they forget to tell you about it because it's so standard in their eyes. But it's only when you've actually seen it in practice and, you know, been there. I don't say go all out and get prodded and, you know, be elaborate, but at least have that conversation. And if you have the opportunity to go along and observe what they're doing, I think that's definitely a great opportunity and not wasted time at all. All right, I think my voice survived it. This is it for me. I just maybe take this last slide as a quick opportunity to advertise for our new statistical consultant unit weblog. It's still short on content at the moment, but we'll be building across the year. So we are writing monthly about all things statistics, what's happening in the world, and I'm sure COVID-19 will play a role at some point in the next few months. But I'll leave it here, and I think Susanna will answer questions. Oh no, I'll answer questions. You pose them.
I will ask the questions. Thank you so much, Marijke. That was a great talk. And I love how you made so clear the importance of statistics, but also just really practical tips on how we can go about it. So people, please enter any questions you have. And I already have one question from Adrian. So the question is, do the sports journals have statistical editors and or reviewers?
Yep, good question. Not as a general rule, I think. So I happen to be the statistical editor for the Journal of Sport and Science, Exercise and Science and Medicine and Sport. But that is because the editor is actually my former boss, so he brought me on the editorial board, so that was quite convenient. The high-ranked journals have at this point all banned magnitude-based inference, so they have taken the advice from statisticians on board, and a lot of them I think also have now a checkbox option for reviewers if it has to go out to statistical review. So then a review can declare themselves not completely capable of judging the statistics part of the paper, and then they can send it out for statistical review. But I don't think as a general, there's not enough statisticians involved, I think, in that area to have one on every single journal.
Thank you. Yeah. Do you have any other questions at the moment? which of the projects was most rewarding for you to be involved with?
I think it's a hard one because they all kind of gave me something. The first two, obviously, I was still very young and new to the whole research thing. So in hindsight, I regret not questioning more at the time, because obviously my reflection now is having learned a lot more across the years. But I think particularly my time at CSIRO and University of Canberra has learned me that value of connecting with the researchers and really embedding yourselves in them, in their domain. So because they have a kind of a natural anxiety towards statistics. So I think it's a bit our job to reach out the hand and get it a bit closer to them for them to actually then take that and build that connection.
Excellent, and that flows on nicely to a question from Jordan. So you spoke about young statisticians getting their hands dirty. He's recently graduated in a role where doesn't use his expertise. So what would be a good way to get more practical experience?
Ooh. That's it really depends on where you are. I think a lot of my when I was very lucky at CSIRO that I was supported to actually get my hands dirty, and it was almost part of my role there. But I did do a lot of kind of talking to researchers, and if they went out on the weekend, go with them. When I was doing my PhD, one of my friends was doing her PhD collecting cheetah poo, basically, in zoos. So I went along with her, and it was very interesting while I was just there and, you know, just having a friendly day out. I did observe a few things that in the end I talked to her about and say, like, look, I know this is your question, but the way your data are being collected at the moment might, you know, pose these issues to actually answer that question. So I guess is try to find the opportunity where you can, even if it's on the weekend or even if you think it's just hanging out with your mates. So if you talk to someone else who is using statistics, try to learn what they're exactly doing. And if you have a chance to go along and, you know, collect some poo or whatever, it could be a fun day out.
You have the best days. Awesome. There's another question from Galia. Sorry if I mispronounced your name. So it just says, thank you for this amazing presentation. They just finished a master's in psychology. They're getting into a master's of statistics. According to your experience, would you have any recommendations on important things or subjects to master to facilitate the transition?
I'm assuming she is talking Australian context, and it's a bit different because in Belgium the whole system was slightly different. So I already had during my master's in psychology statistic units every year. So there was a natural flow on to that master's that I did, which was actually a master's after master's. So in Belgium, the system is that everyone obtains a master's pretty much. And so there's no honours system. In terms of in Australia, I think with the master's, if you get a chance to do research methodology related subjects or experimental design related subjects or the more hardcore statistics subjects, I think those are all definitely valuable. With the research subjects, I think it's important to get those because you understand their specifically the types of research that are being done, and then if you then can link the statistics to those types, it helps a lot in practice to make that link between what the people are doing and then what their analysis will look like.
Awesome, thank you. Does anyone else have any questions? So have you had a question from Shichu? So have you had much experience in statistical consulting outside of an academic context? How is that different from engaging with academics?
Well, the short answer, no. I think I've been in university for almost 18 years now. I guess CSRO can also be considered academia. So not consulting. I have worked while I was with CSRO with several government departments. I think the main difference there is that they really need the plain language. Um, and they don't deal very well with the non-black and white answers. So if you're not willing to go one way or the other, you still need to use clear language to indicate that, you know, there are 1, 2, 3, 4, 5 possibilities. But they do want to see it in a very clear kind of way, I think, of at least that's my experience, because people don't like uncertainty.
Definitely makes it more challenging. Still just checking to see if there's any last questions. So yes, question from Rachel. If a non-statistician is opposed to the best practice statistical methods, do you have advice for asserting yourself and leveraging your knowledge without coming across as combative?
Yeah, that's a very good question. So while I was working in sports science, I did manage to convert people working closely with me. I think the main reason for that was that I built a rapport and a certain trust level, because I was willing to speak their language. So I was willing to try to translate. I listened a lot the first few months. I listened to them constantly, and I did really not say anything, or that's wrong, or that's, so never say that they're wrong. Because that is creating that standoffish. As soon as you feel you have that level of trust, then you can start pushing. Then you can start saying like, I understand that this is the way you've been doing it, but have you considered that maybe this could be useful because of these and these reasons? So again, in a very positive language. And I think that's probably the maybe the issue a bit with the reviews that have been published, because they are so clear and they are creating that standoffish kind of reaction, and it goes this like yes and no kind of debate. But it's again about reaching out that hand and making sure that you're both on the same page first about other things, and that, you know, they know you value their research, and then you can start prodding and, you know, moving them towards where you think things should go.
Yeah, nice. Sounds a bit like boiling frog.
Yeah.
Excellent. I don't see any more questions. So we might draw it to a close. So I do want to thank you again, Marijke, for an amazing presentation. I also want to thank Mark Wicht for outstanding behind-the-scenes technical support. He put so much effort into each webinar. And I want to thank all of you for coming and attending. So keep safe, keep connected, and know that your society is here for you. And we hope you enjoy the rest of your day, and I hope to see you at a future webinar. Thanks very much.
Thank you. Good afternoon, everyone.